Welcome to today's deep dive. We're going to be getting into the 2024 Nobel Prize in Physics.
Hmm.
And you're not going to believe this, but it's all about machine learning.
It is. Yeah.
I know, right? When you think physics, you probably think, oh, like black holes,
Right.
quarks, all that kind of stuff.
Exactly. Yeah.
But trust me on this, it's cool.
Yeah.
Basically, it's about how physicists literally shaped the digital world that we live in.
Yeah. It's really remarkable when you think about it.
It is.
It really highlights how intertwined these fields are.
Right.
We're talking about using the laws of physics to understand and even replicate something as complex as learning.
It's wild, right?
Yeah.
Okay, so imagine trying to teach a computer to recognize a cat, right?
Okay.
You wouldn't program in every single little detail.
Yeah.
You'd show it a bunch of pictures of cats, just like we do with kids, right?
Exactly.
Just be like, look, this is a cat, this is a cat, this is a cat.
Yeah.
That's machine learning at its core. And this is where John Hopfield, one of our Nobel Prize winners, comes in.
Yeah.
He blew the field wide open with this idea of associative memory in neural networks.
Right. And, think about how our brains work.
Okay.
You're trying to remember a word.
Yeah.
And so you start thinking of similar sounding ones.
Right.
It's like your brain is searching for connections.
Yeah.
Hopfield figured out how to build networks that do the same thing.
Wow.
They can actually reconstruct complete information even if the input is a little incomplete or a little fuzzy.
So it's like those puzzles
Yeah.
where you can still kind of see the image,
Exactly.
even with some pieces missing.
Exactly. And what's even more amazing is how he did it.
Okay.
He used principles from physics, specifically the way magnetic materials behave, to model how neurons in the brain might interact and store information.
Wait, so he used magnets to understand how our brains work?
In a way, yeah. It's this elegant connection between these seemingly different realms.
That's incredible. I mean, what kind of impact did that have? Where do we see that today?
Oh gosh, everywhere. Think about the technology we use every day.
Okay.
Facial recognition on your phone.
Right.
That's based on Hopfield's work. Autocorrect saving you from typos. Hopfield again. Even the analysis of medical images to diagnose diseases.
Yeah.
It all has roots in his research.
It's mind-boggling how something discovered back in the 1980s could have such a huge impact on our lives today.
It really is. It speaks to the power of fundamental research,
Yeah.
These groundbreaking ideas often have ripple effects that we don't even fully grasp at the time.
Right.
And, the story doesn't end there.
Okay.
We've got another Nobel laureate to explore, Geoffrey Hinton, who took this idea of machines mimicking how we learn even further.
Okay, you've got my attention.
Yeah.
Let's talk about Hinton.
Okay.
What makes his work so groundbreaking?
Well, you see, Hinton, he was fascinated by how machines could not just store information,
Right.
but truly understand it, how they could learn to classify and interpret data
Okay.
like we do.
So, moving beyond just recognizing a cat in a picture
Exactly.
to actually understanding what a cat is.
Precisely. Think about how effortlessly children learn to categorize things.
Right.
They don't start with complex definitions.
Yeah.
They learn by recognizing patterns, similarities.
Right.
And Hinton wanted to find a way to replicate that in machines.
That's incredible. How do you even begin to teach a machine to think like that?
Yeah.
And where does physics fit into all of this?
Okay, well, that's where Hinton's groundbreaking work on the Boltzmann machine comes in.
Okay.
It sounds like something out of science fiction, I know,
Right.
but it's actually rooted in the principles of statistical physics.
Okay, you're going to have to break that down for me.
Oh, sure.
Statistical physics.
Yeah, so imagine a container filled with gas molecules,
Okay.
all bouncing around randomly, right?
Yeah.
Statistical physics helps us understand and predict the overall behavior of these molecules. Even though each one is moving unpredictably,
Okay.
Hinton realized that he could use similar principles to model how a network of neurons could learn to recognize patterns and make decisions.
So instead of predicting the movement of gas molecules,
Yeah,
he was predicting the probability of different patterns showing up in data.
you got it. And here's where it gets really mind-bending.
Okay.
The Boltzmann machine, using these principles from physics,
Yeah.
can actually generate new data that resembles the examples it was trained on.
Wait, so you're telling me that this machine can learn to create something new
Yes.
based on what it's already seen?
Yes.
So could it, compose music if you fed it enough Mozart?
That's the idea.
Yeah.
Hinton's work laid the foundation for what we now call generative models.
Okay.
These are algorithms that can create art, music, even design new drug compounds.
Wow.
all thanks to the fundamental principles he borrowed from physics.
Okay, that's just unbelievable.
Yeah,
So we've gone from magnets and brains to gas molecules and AI composers.
I know. It's amazing.
It feels like we're on the edge of something huge here.
We are. We are.
Where does it go from here?
Okay, well, this is where things really start to take off.
Okay.
Remember how we talked about those early neural networks
Yeah.
having a few hundred parameters at most?
Right, right.
Today's large language models, the ones powering things like ChatGPT,
Right.
they're working with trillions.
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 Yes.
This leap in scale and complexity is what we call deep learning.
Okay.
And it's transforming the world as we know it.
Trillions of parameters. It's hard to even wrap my head around that.
It's massive.
And to think it all started with these fundamental ideas from physics.
I know, it's remarkable. And it's not just about building more powerful computers.
Okay.
Deep learning is now being used to solve some of the most complex problems in physics itself.
Now that's what I call coming full circle.
Yeah.
Give me an example. What kind of physics problems can we solve with algorithms inspired by our own brains?
Okay, well, think about the Large Hadron Collider.
Okay.
That massive machine that smashes atoms together at nearly the speed of light.
Right.
It generates an overwhelming amount of data.
I bet.
Deep learning algorithms are helping physicists sift through that data
Oh, okay.
to find evidence of new particles, new forces, even new dimensions.
Wow.
It's like finding a needle in a haystack the size of a planet.
Whoa. So we've gone from recognizing cats in pictures to unraveling the secrets of the universe.
I know, it's quite a journey.
That's an incredible leap.
It is, and it doesn't end there.
Okay.
Deep learning is revolutionizing fields like medicine and materials science.
Right.
Imagine being able to predict the properties of a material before it even exists.
Oh, wow.
Designing drugs atom by atom just by feeding data into a model.
Right.
The possibilities are truly mind-boggling.
It's almost too much to take in. But it also makes you wonder
Yeah.
if we can build machines that can learn and solve problems like this, what does that say about us?
It's a big question.
What does it mean to be intelligent in a world where machines are rapidly catching up?
That's the most profound question of all, isn't it?
Yeah.
And it's one that we'll continue to grapple with as these technologies evolve.
Right.
But one thing is for sure. The future of deep learning is inextricably linked to the fundamental laws of physics that govern our universe.
That's an amazing thought. It really is.
It is.
So to wrap things up, it seems like we've barely scratched the surface of what's possible with machine learning.
Yeah, we're just getting started.
But it's clear that these breakthroughs wouldn't be possible without the pioneering work of physicists like John Hopfield and Geoffrey Hinton.
Absolutely not.
Their insights into the nature of information, learning, and computation have fundamentally changed how we interact with the world.
They really have. Their work is the foundation for so much of what we take for granted today.
It's true. It's true.
And as we venture further into this uncharted territory,
Yeah.
it's more important than ever to approach these advancements with a sense of responsibility.
Right.
And
Wise words. Well, that's it for today's deep dive into the world of machine learning and the 2024 Nobel Prize in Physics.
it's been fun.
I don't know about you, but I'm walking away with a whole new appreciation for the interconnectedness of science and the power of human curiosity.
Me too. It's been a pleasure exploring this fascinating topic with you.
Thanks for joining us, and until next time, keep asking questions and stay curious.
Absolutely. Curiosity is key.
It really is awe-inspiring when you think about it, right? We've gone from these elegant theories about magnets and gas molecules
Yeah.
to algorithms that can unlock the secrets of the universe. It's like physics has given us this incredible toolkit to explore not just the external world,
Right.
but also the inner workings of our own minds.
It's a beautiful illustration of how scientific knowledge builds upon itself.
Yeah.
You know, we wouldn't be where we are today without the curiosity and ingenuity of those who came before us.
Yeah.
And as we continue to push the boundaries of what's possible, who knows what other astonishing connections we might uncover.
It's both exciting and a bit humbling, isn't it?
It is.
Like, here we are just beginning to grasp the power of machine learning.
Yeah.
And it's already challenging our understanding of intelligence,
Right.
creativity, even consciousness itself.
It's a powerful reminder that the pursuit of knowledge is a never-ending journey.
Yeah.
The more we learn,
Right.
the more we realize how much more there is to discover.
It's true.
And that sense of wonder, that drive to explore the unknown, that's at the very heart of what makes us human.
Beautifully said.
Thank you.
So as we wrap up our deep dive into the world of machine learning and the 2024 Nobel Prize in Physics, I'm left with a sense of awe and
Yeah.
a whole lot of new questions.
As you should be. That's the beauty of it all.
Yeah.
Every answer leads to new question,
Right.
propelling us further along this incredible journey of discovery.
It's been an absolute pleasure picking your brain today.
Oh, likewise.
Thanks for joining us on this deep dive.
The pleasure was all mine, really.
And to our listeners, we hope this episode has sparked your curiosity
Yes.
and left you with a deeper appreciation for the incredible world of science and the power of human ingenuity.
It's an amazing world out there.
Until next time, keep exploring.